Imagine this. A weapon that can travel for months beneath the ocean floor. In a realm where sunlight has never touched. No radar can see it. No sound escapes its path. And when it rises, there will be nowhere left for mankind to hide. Thousands of meters below, in eternal darkness, a shape the length of a 10-story building drifts in silence. It has no crew, needs no fuel, awaits no command. It has only one purpose: to erase an entire civilization. Orientation, origins, purpose, and the strategic blind spot. 2018, Moscow. Behind Vladimir Putin on a screen, a simple animation plays. A tiny dot leaves the Russian coast, crosses an ocean, detonates off the American shore. The official name begins to surface: Poseidon. Internal documents label it Status 6. It is not a missile, not a submarine. It is an autonomous, nuclear-armed torpedo, built to travel across continents and launch from a mother submarine. A new class of weapon born to answer an old question. When every eye in the sky is watching, where does war still hide? In nuclear deterrence, the core is the assured second strike. If land and air-based forces are wiped out, the ocean remains deep, cold, hard to detect. The mere existence of Poseidon sends a message. Even if we fall, this thing will still arrive. In the salt dark, submarines are the access of modern conflict. Stealth platforms that live for weeks or months underwater, carrying torpedoes, smart mines, cruise missiles, and even SLBMs. Strikes aimed at an enemy's logistics lifeline and strategic nuclear deterrent. Why the deep sea? Because modern defenses have inherent blind spots. Sound travels slowly underwater and blends with the ocean's noise. Thermal layers bend sonar paths and create pockets of no sea. Rugged seabeds scatter echoes into chaos. Where physics creates darkness, asymmetric strategy finds opportunity. A submarine's strength is not only its firepower, but its endurance and silence. Listen more than speak. Pick the decisive moment, then vanish. The trade-offs are real. Limited communications, difficulty in real-time targeting. But the reward is persistence and ambiguity. For Russia, Poseidon is a strategic insurance policy. It need not punch through aerial missile defenses. It does not rely on jam-prone satellites. It does not require continuous command links. It is designed to outlast human error. The political message is built into the architecture. Low profile, able to crawl deep and slow when necessary, surge when it's close. Its path hugs the seabed rather than following a ballistic arc. The weapon's power is measured in time as much as yield. Not today. Maybe next month. In that interval, the opponent must guess. Uncertainty becomes the weapon. You do not know where it is, when it will arrive, or how to dome cover every coastline. And sometimes mere demonstration is enough. Poseidon does not need to be fired to change the security equation. In nuclear war, sowing doubt can be more dangerous than any single blast. Structure and technology. Look at the machine and strip away the slogans. What's left are shape, materials, energy, and the way it moves in the dark. First, scale. Poseidon is roughly the length of a large city bus, about 20 to 24 meters, approximately 65 to 79 feet. Its body diameter sits near 1.8 to 2 meters, approximately 6 to 6.5 feet. Mass estimates range from 50 to 100 tons, depending on configuration. This is no ordinary torpedo as civilians imagine it. It's a large autonomous device, pressed into a long, slender cylinder to minimize drag at extreme depth. Cost figures are not publicly disclosed. Any exact numbers you see online are speculative. But production costs for Poseidon almost certainly eclipse those of conventional undersea weapons because of the nuclear package and the demands of stealth and long-range durability. The hull materials must survive crushing pressures. 800 to 1,000 meters down equals roughly 80 to 100 atmospheres. So the pressure-bearing sections are likely high-strength steel or titanium alloys. Weaving choices Russian deep-diving projects have historically favored. The exterior is wrapped in anechoic coating, sound-absorbing tiles that eat sonar pulses and reduce reflections, making active sonar returns weaker. Every weld, every seal is built like a deep submersible, not a tactical torpedo. Propulsion is not a conventional propeller. It uses a pump jet, a shrouded water jet rotor inside a duct. Advantages: far quieter underwater, fewer bubbles, lower acoustic signature, and rotating components hidden within a protective housing, all of which make detection far harder. When needed, it can reportedly sprint. Sources speculate burst speeds up to 100 knots, approximately 185 kilometers per hour, for short periods. But over most of its transit, it moves very slowly. Underwater acoustics reward patience. At the heart sits a compact nuclear reactor. Unlike chemical fuel, a reactor supplies continuous power for weeks or months. So practical limits are no longer fuel tanks, but mechanical and electronic reliability, and how materials hold up to salt, pressure, and time. Deep water navigation cannot use GPS. GPS is a high-frequency radio signal, microwave, and radio barely penetrates seawater, especially at depth. Poseidon must rely on high-precision inertial navigation, laser gyros and accelerometers, combined with geomagnetic mapping and bathymetric matching. In short, it reads the ocean with its ears and its memory. It listens passively rather than pinging. It follows deep trenches and slopes where thermal layers bend sonar paths and create blind pockets. The warhead, according to public sources and open analysis, is nuclear, with yields discussed in the multi-megaton range. The effect is not only blast and a towering column of water. A near-shore detonation produces destructive waves that demolish infrastructure, followed by radioactive contamination that renders coastlines hazardous, wrecks livelihoods, and disrupts supply chains for years. Such a strike may not erase a country, but it can erase the economic future of an entire region. The real danger is the combination. nuclear yield plus acoustic stealth, plus seabed-hugging guidance, plus near-indefinite loiter time. Together, these turn the ocean floor into a silent deterrent chamber, a strategic spear the adversary cannot easily locate or neutralize before it's primed. Poseidon doesn't act alone. It requires a mother submarine, vessel classes designed to carry and launch the system. Defending against it is no longer just find a torpedo, but hunt a whole system. Detect the mothership, trace ingress routes, and interdict launch points. That demands ASW at a different scale. Seabed sensor nets, buoys, maritime patrol aircraft, hunter-killer ships, and unmanned undersea vehicles. A multi-front hunt to pierce built-in invisibility. And finally, the haunting question. If you cannot know where it is, how can you be sure it isn't right beneath your feet? Poseidon turns deterrence into the unprovable, and that very unprovability reshapes strategy, politics, and coastal security in the 21st century. Next, we'll move into how Poseidon is deployed and reaches its target: the mother submarine, the launch sequence, ingress corridors, and operational tempo to assemble the full tactical picture.
Deployment and strike sequence. Start with the system's heart, the mother submarine. Belgorod, Project 09852, is the platform now in service. A stretched Oscar II hull modified for Juji's special missions. Launched 2019, commissioned 2022. About 184 meters long, submerged displacement over 30,000 tons. Belgorod is both a Poseidon launch platform and a mothership for deep-diving submersibles and seabed robots. Its advantage: huge carrying capacity and long range. Its limitation: an acoustic heritage from the Oscar design, even if noise has been reduced. Today, there is only one operational Belgorod, but the weapon it carries is already enough to unsettle the world. Khabarovsk, Project 09851, is the purpose-built follow-on. Designed from the keel up to be quiet, sealed, and precise in launch, said to inherit low-noise engineering from the Bore class. It's in trials and expected to join the Pacific Fleet around 2026. Smaller and sleeker than Belgorod, its philosophy is different. Minimize acoustic signature, make detection harder, focus solely on carrying and launching Poseidon. If Belgorod is a workship, showing off payload and multi-role seabed capability, Khabarovsk is the scalpel. Low noise, hard to find, there at the right place and time. The two approaches complement each other and thicken the deterrent chain. Launch does not happen at the shoreline. The mother submarine selects deep water with strong thermoclines and complex seabed topography. Launcher doors open. Poseidon separates in a quiet configuration and shifts to passive transit. From that point, communication, if any, is limited to a handful of ELF/VLF characters. The rest is handled autonomously. High-precision inertial guidance, geomagnetic fixes, and bathymetric matching. The ingress route is not a straight line. Poseidon hugs the seabed through deep channels, submarine canyons, and slope faces, areas where fixed sonar is least effective, while exploiting thermoclines to bend sound propagation. It can skirt less monitored continental shelves and enter from unpredictable approaches. Most of its voyage is slow and stealthy. Only in the final phase will it sprint briefly, when natural acoustic masking around the target is favorable. Near the coast, Poseidon does not need to penetrate air defenses or seize the surface. It detonates offshore at an optimized depth to combine three destructive effects: the blast pulse, the column of water thrust, and long-term radiological contamination. The strike is aimed not at a single building, but at the habitability of an entire littoral stretch, ports, energy infrastructure, logistics, and the public belief that a region is safe enough to live in and conduct commerce. Defenses is not helpless, but it is stretched. Intercepting such a system requires layered sensors, seabed sonar belts at strategic choke points, hunter-killer submarines and maritime patrol aircraft, unmanned undersea and surface vehicles, smart mines in straits, and machine learning signal analysis to tease tiny signatures from ocean noise. Poseidon has moments of vulnerability, right after separation from the mothership, during the final sprint, or if forced to surface to deploy a communications buoy. Catching it in one of those windows requires sensors that are always on, synchronized, and incredibly sensitive. In the next section, we will simulate a coastal strike. Approach corridors, detonation timing, radius of effect, and what remains after the first minute, the first day, and the years that follow.
Case study. What does a single Poseidon strike on a coastline look like? Imagine a quiet morning at Harbor X. Ship horns, gulls, the water flat as glass. Then the sea rises. There's no flash in the sky, no thunderclap overhead, just a deep grinding roar, as if someone snapped the ocean's spine. A vast dome of water bulges up from the deep, surges skyward, then collapses like molten metal. The underwater shock slams outward like a hammer, compressing water into something almost like liquid steel for a fraction of a second, sending devastating pressure in every direction. Moored vessels pop free like toys. Glass shatters in arches along the quay. Not from the wave itself, but from the shock wave transmitted from sea to air, bending the very atmosphere. The first strike is pressure. The second is the water wall. Not the mythical super tsunami, but enough to swallow a harbor shelf, topple containers like dice, snap cranes like matchsticks. The massive column of water pushed up and then dumped back down creates violent negative pressure suction, ripping concrete structural layers apart. Water floods everywhere: engine rooms, cable vaults, fuel depots. Salt water is a conductor. When it floods electrical systems, it shorts substations, trips breakers, and sets off cascading failures. Transformers pop, underground cables burn. 15 minutes later, the port is dead silent. Power stutters and then goes out. Not for lack of generation, but because the grid is salt contaminated and automatically isolates to prevent secondary fires. Power plants are waterlogged. Undersea cables arc and fail. Factory sensors scream faults. Fuel depots along the shore ignite when pressure waves rupture tanks and tear safety valves. Amid the chaos, the sea begins to exhale radioactivity. Salt spray rises, mixes with contaminated particulates, and forms a low, invisible mist that creeps inland on the wind. You do not smell it. You do not hear it. Only when Geiger counters start screaming, throats burn, and skin tingles like acid do you realize the air itself is poisoned. Emergency rooms overflow. Ruptured eardrums from pressure, lungs burned from inhaled radioactive salts, skin blistered from toxic exposure. Engineers shout, "Shut the valves! Evacuate! Cut power!" No one asks what exploded. Only how many minutes until we lock down the shore. 24 hours later, the nation's map glows with a silent red along the coastline. Coastal highways are severed. Small airports close as wind whips radioactive dust across runways. Cargo ships turn and steam for open sea. Freight rates spike. Domestic suppliers are ordered, "Do not accept, docks unsafe." Weeks later, the second catastrophe begins. Radioactive sediments settle in enclosed bays, lagoons, and channels, places where water stands and time stops. Fish vanish. Boats sit beached. These waters become time traps no one will touch. Risk maps paint the coast in red. People who once dreamed of seaside homes ask only, "How fast can I leave?" Insurance goes quiet. You can rebuild cranes, replace piles, splice cables. But trust, the belief that this shoreline is safe to live, work, and trade, is not restored overnight. Every southerly breeze carries the same question. Is today safe? And no one is confident enough to answer. The cold truth: you don't need a mushroom cloud to erase a port city. One offshore detonation, at the right depth, with the wind where it matters, and timed with the tide, can freeze a regional economy for years. On the horizon, you can watch war arrive. Under the sea, you only ever see what comes after.
Silence is not safety.
The deep sea has no warning horn, yet beneath its surface sit machines capable of changing the fate of a nation. The facts are plain. It's small compared with a submarine, only about 20 to 24 meters long, approximately 2 meters in diameter, but catastrophic in consequence. Ports closed indefinitely, supply chains severed, fisheries halted, radioactive sediments settling, and public trust in the coastline erased for months or years, potentially costing millions of lives. It is a predator lying in wait, ready to strike at any moment. The race is no longer who can fly faster. It is who can hide deeper, wait longer, and be harder to find. One side reduces noise, hugs the seabed, and goes dark. The other must blanket the seas with sonar, P8s, USVs/UUVs, and AI that analyzes background noise 24/7, just to detect a whisper amid the ocean's roar. Arms races are costly. Tomorrow, AI will infiltrate every weapons system, even under the sea, even Poseidon, even the mother sub. One software bug, one spoofed sensor, one algorithm 99% confident. Command chains could link straight to a nuclear volley. Automatic, clinical, without debate. Decision speed compresses from hours to seconds. Humans slip out of the loop at the moment their judgment matters most. Full nuclear disarmament? Lovely on paper, perilous in the field. Mutual distrust among great powers runs deep. Deterrence is treated as survival insurance. Seabed monitoring, bunkers, dual-use tech. None are foolproof. One smuggled device and treaties collapse. So what must we do now? Enlarge decision windows. Keep humans in the loop for launch authority. Ban AI-driven automatic firing and increase transparency. Multi-layered cross-monitoring above the sea, below it, and inside the data itself. Now answer 2 questions.
Question 1. If an AI system mistook a noise track for a nuclear threat, who should press the final button? A responsible officer who understands consequences, or an algorithm that cannot know regret? Question 2. If today's peace rests on nuclear fear, do we dare trade that fear for a weapons-free world tomorrow? Or will we trap ourselves forever in a cycle of deterrence? This is Future War Tech. We'll see you in the next episode.